In this video, we're going to take a look at the integration of exponential functions, and looking at this question here, we're actually going to need to do some work on it before we can integrate it, and that is because we can integrate a to the power of x. We know that that goes to a to the x all over ln of a, and of course if it's an indefinite integral we'd put our plus c. So I'd have to get it down to a to the power of x, not a to the power of 2x, but a to the power of x. So one way I can do that is by using my indice rules, and I would have 2 to the 2, which is going to be 4, and then it's going to be to the x. So we just actually have a question that's asking us to integrate 4 to the x. And there's actually 3 ways that you could go about this question. So the first way is using the log tables. If we follow the log tables, the rule, again, like I wrote above, if we integrate a to the x, it goes to a to the x all over ln of a plus c. So integrating that, it's going to become the integral of 4 to the x becomes 4 to the x all over ln 4 plus c. Another way I could do this is by writing that 4 to the x, so we have the integral of 4 to the x, by rewriting that as the integral of e to the ln 4, and all of that's to the power of x. So what I've done there is I've replaced the number 4 with another representation of the number 4, which is e to the ln 4, and that's a rule in the log tables as well. So that then I can write as the integral of e to the x ln 4, which then is going to become the same thing as if we were to integrate e to the 4x. What we would do is we would divide by the coefficient here, which in this case is going to be ln 4. So we're going to get e to the x ln 4 all over ln 4. And finally, the last way to do this is going to be using our u substitution. So what we could do is we would have our integral of 4x, or 4 to the x rather, and we're integrating that with respect to x. Again, what I could do is rewrite it as e to the ln 4, and it's going to be all to the power of x. And when we have a power raised to a power, we multiply them, so it's actually e to the x ln 4. So that's what I'm integrating. So I'm going to say, alright, that's a little bit awkward. So what I'm going to do is take out the part that I'm unsure about, and I'm going to replace it with the letter u. So I'm going to take out that and replace it with the letter u. Now, when I integrate that then, I can't integrate it with respect to x. I'd have to integrate it with respect to u. Now, it's not as straightforward in this instance as swapping dx for du. We actually have to find out what dx and du, what connection there is between them. So we do that by using our differentiation. So if u is equal to x ln 4, then du dx, and here's the connection, du dx is going to be, and this you could work out using the product rule, it's just going to be ln 4. I can multiply up by the dx, and I'm going to get du is equal to ln 4 dx. And then from this I'm going to get that dx is equal to du all over ln 4. So that's what I can replace my dx with. So it's a little bit trickier than the other methods. It just takes an extra step or two. So that's what we're going to replace our dx with. So it's not as straightforward this time as swapping them out. So we're going to say multiply that then, or well, multiply it by 1 all over ln 4, and we're integrating with respect to u. What I can do with this, because it's a coefficient and it's multiplying, I can take it out. So I can say 1 all over ln 4, and it's going to be the integral of e to the u, and we're integrating it with respect to u. So I'm going to move this over here so we don't get it in the way. When we integrate e to the u, it stays as e to the u, and we multiply in our ln4. So we've got ln4 and e to the u, and let's not forget our plus c. Our e to the u, remember, is e to the x ln4, and that itself was 4x. So we still get the exact same thing as before, which is 4 to the x all over ln4 plus c. Just a different way of finding the answer.